so today we're going to talk about effective use of business analytics. And really, this is an overview presentation of a workshop that we do that is a 2.5-day workshop with clients to help them, what's called the Business Analytics Maturity Assessment. So to help them utilize analytics better, more effectively within their organization. So I will try to go through all this in the 50 minutes that we have, but realize that we could spend hours and days, and we do, talking with clients about their situation and how we could help them use analytics in a better way. How many of you guys are analysts, or people, statisticians, anything that has to do with analytics? How about business people? Would you consider yourself business people? Okay. How about IT? Oh, one IT guy. All right. Well, what we try to do in these workshops is we try to bring business, IT, and analytics together. Okay? I know that sounds a little scary. I heard yesterday that people were talking about the chasm between business and analytics. There's an even bigger chasm between business, analytics, and IT. So that's why we're trying to get common ground, common understanding of analytics. What does it mean within your organization? What are some of the challenges? Because really, we used to be able to implement analytics in the business unit with a couple of people who knew something about analytics, and we would have our own servers there. But the data's getting bigger. IT is getting stronger within our organizations. They don't like it when we create shadow IT environments. And as that environment grows and we get more and more data, we can't implement analytics without the IT groups. And it never became more clear to me. I don't usually go to IT type of conferences. And I had to fill in for one of my colleagues last year. I went to a CIO's conference. And they were releasing results of a survey that they had about analytics. And the discussion was absolutely incredible. The IT people sat there and said, you know what, those business people, they're holding back from us. They're holding back information. They know exactly what they need, and they won't tell us. And I'm thinking, are you kidding me? They don't know. They want to know the answer to their business questions. They want to know, who should I mail to, right? I have all these customers or prospects, and they want to answer a business question. And they don't know how to figure out the analytics part of it, and they don't know how that translates into what data is in the data warehouse. They have no idea. They're not holding back from you. And it was just kind of an eye-opener for me. And now I have to kind of turn my presentations into simple examples for IT to understand why they collect, how they collect the data is not at all how we're going to use it in the analytics part of things. It's not at all how we're going to use it. So the first thing that we typically do in these sessions is, and this is what I'm going to talk about today, the difference between analytics and business intelligence, which I think most of you would understand. We've heard a lot about that. Analytical maturity, trends in analytics. And the reason I'll tell you about trends in analytics is it's going to affect and impact how we implement analytics in our organization and the challenges that we'll have in the use of that. We feel like it's critical to have a center of expertise in your organization around analytics. And as you mature, you'll kind of group people that have expertise together, centralize them at some point in time, and then that centralized group can help expand the use of analytics outside of that centralized group. And it may be ebb and flow. You might start out with decentralized and come to centralized and decentralized. But as you're getting started and as you're growing, it needs to be a couple of people at least that can bounce ideas off of one another, that can collaborate, that can make the answers that you're going to provide to your business users better. And then where do you start? So that's what we're going to talk about. And I know that's a huge challenge in 40 minutes. So I've used this slide for a really long time. It still stands today. You know, analytics is in vogue, right? People are collecting all this information, but they can't analyze it fast enough, and they're still making very, very uninformed decisions. Would you guys agree? I see a lot of heads nodding. So we start in these workshops with the definition of analytics. And people say, you know, why should we care about better models? You know, we can use Excel. We have, you know, models that we use. And again, I tried to get simple examples out to these guys and level set everyone. Usually pick on somebody in the audience. How many of you guys drive to work every day? How long does it take you to get to work?
35 minutes.
About 35 minutes, approximately, average, on average. Is average a model? It is, right? You know, you've assessed in your mind, yeah, how long it takes, yeah. Is it good enough?
No. Because I live in the Washington, D.C. area, and 35 minutes could turn into 3 hours.
So it might be good enough if there's no penalty, right? It might be okay, right? But if I tell you tomorrow when you drive to work, or the next time you drive to work, I'm going to charge you $1 for every minute you're off. What if I charge you $1,000 for every minute you're off? Maybe you want to be more precise. Maybe you want to know what day of the week, what time of day, what's the weather like, is there a traffic event, right? Are the bridges closed? You know, you want to get more information to be more precise, because now there's a cost or a risk associated with it. So is your average model good enough? Maybe. Maybe that's all you need if there's no penalty or risk associated with the decision that you're trying to make. But why do we spend all this time getting the best, most precise models? Because it usually costs us a lot of money, one way or another. Risk, money, cost, some kind of effect, right? So that's why we talk about reducing uncertainty, predicting with precision, because of the costs associated with that. So what is analytics? Oh my gosh, that's scary for business and IT, right? We got a lot of methods, lots and lots of methods. So we try to kind of combine things so it's not as scary. And in these sessions, we level set on each of these things. You know, statistics being primarily, again, easy explanations, right? Comparing sets of populations. Is sales in one region significantly different than sales in another region? If someone takes a certain type of treatment in healthcare, is it significantly different than the control group that doesn't get that treatment, right? So statistics are comparing these, but you have a hypothesis that you're trying to test. Whereas data mining, you have a target, you're trying to figure out who's going to, let's say, respond to a particular marketing campaign, or when a product might be likely to fail, right? But you don't have a hypothesis. You're letting the data and the patterns in the data describe to you what's going on there to figure out what are the most important or impactful variables within that analysis. So that's the predictive analytics, where we would start in the data mining. Forecasting is also predictive analytics, but now we put a time dimension to it. So we're looking at how many in a specific time period. So not only who is likely to respond, but how many in the next 3, 6, 9, 12 months, right? Or when is our CPU utilization going to get so high that we need to buy new machines in the next 3, 6, 9, 12 months? When are we going to need new people, more people in our organization to staff our call center? How many and what time frame? So also predictive analytics, but now we put a time dimension to it. Now text analytics is one of my favorites because it's a data source that people are not taking advantage of. We hear that 80% of an organization's data is textual, whether that be documents or call center notes or warranty analysis, right? They're collecting it, it's growing at something like 61% compound annual growth rate as compared to structured data, which is growing at about 21%. But they're not using it, collecting it, using storage, not doing anything. So what people are doing now, what we're doing actually with text, is we're turning text into a numerical representation of that text, whether it be sentiment analysis or some other clustering techniques and topics, and we're then can combine it with the rest of our analytical tools. Right? And so we're combining text, let's say in a call center, you're looking at patterns for people who might leave your business, who might churn, who might go to a competitor, right? And we might use a data mining model to try to detect those patterns of who's likely to leave. But what's more predictive, those patterns? Or when you actually hear someone say, I'm going to leave your business if you don't give me a better rate, right? The text could be much, much more predictive than the rest of them. But combining the two gives you an even better opportunity for probabilities to detect those things. And then, last but not least, finally, the optimization piece of you're trying to minimize or maximize something with constraints in the business. We don't talk about it that way when we talk to business users. We talk about everybody has resource constraints, right? So you might want to maximize revenue, figure out what your best choices are, but we all know that we have constraints around resources and money, and there's business rules and things like that. So to come up with the best choice possible, given the limitations that we have on our resources. And then, told you we'd tell you the difference between business intelligence and advanced analytics, and you see there that business intelligence is kind of that rear view mirror, looking at what happened in the past. And more, visualization is becoming a key part of getting results out to the end users. But it's also something that we can do as we look at the trends, and we'll talk about this a little bit more, that, you know what, how many people in your organization can create predictive models? You have a few, a very small few. But people, everybody, can look at a visualization of data and pick up anomalies, patterns in the data. People are visually oriented. So a lot of people could look at a lot of data visually, many more than your modelers, and when they find something interesting, or what they think looks interesting, they could pass it on to the statisticians or the modelers to kind of dig deeper into that. But when you spread out that the visualization piece of it to other people, then you might find more interesting things within your organization. And obviously, we can't do any analytics without data. And getting the data, accessing the data, bringing it together, cleansing it, all that kind of thing is very important. Yes?
I might be having a Forrest Gump moment. What's the difference between business intelligence and analytics? You were describing that, and I'm not sure if I caught it.
So business intelligence, from our definition, would be reporting. Rear view mirror kind of looking at, versus predictive analytics, which is moving into the future. Data mining, trying to look at what's going to happen, what's likely to happen. All right, this is probably the most important slide in the whole presentation. All right, so the life cycle of analytics. Analytics is actually a process, right? And it starts here at the top. There's a business problem that people come to you, they say, I want to know who are the people that I should mail to, right? Who are the 100,000 people that I should send this offer to, right? They come up to you with that problem. How do I take that business problem and turn it into a mathematical representation of the problem, whatever the problem is, right? That's kind of the first step. And then there's data preparation, exploration of the data, transformation, selection, building the models, the thing that we're so passionate about, right? Building the models. And then the rest of the cycle of deploying the models and getting continuous feedback. Now look at this. There's little colors in here of all the different pieces of this process. And these are the people associated with those parts of the process typically. So it's the business person that comes with the problem, right? And then there's getting the data, IT. There's the data miner or statistician, sometimes called a data scientist these days. And then the business analyst, and we go around here. And the whole process needs to be looked at as we think about how to solve the problem. What data do I have? Where is it? How do I get it? Is it in the right format? So again, IT collects the data in one way, a lot of times in a transactional format, right? I go to a bank, you get your bank statement. What does it say? Here's the date, here's the transaction. It was a check, it was an ATM withdrawal, here's how much it was. Very transaction oriented. But when I want to do a data mining problem, I have to take that data and I have to put one row in my database per subject customer in this instance. Everything I know about Kathy Lange needs to be in one row of that database. I need to figure out, how much she's got in savings, how much she's got in checking, what are her loans, what are the amounts that she's taken out, and I have to transform that data. That's kind of a big transformation, but there's also small transformations in the data. So when I go to my doctor and they take my blood pressure and my cholesterol, right? Cholesterol they collect as a continuous variable, right? Somewhere between probably 100 and 400, right? When I go to analyze data about patients and healthcare, I don't care what the actual number is. Most likely I want to group that information as to low cholesterol, normal cholesterol, high cholesterol, maybe extra high. So you have a couple of bins, a couple of groups of that data. Guess what? That doesn't exist. That data in those bins does not exist in the data warehouse. You have to add another column in the warehouse. Or maybe not in the warehouse. There's where IT doesn't understand that how they collect the data isn't the same as how they're going to analyze the data, right? So what do I do about that column of data that I need for my analysis? That variable that I've just created, and there's thousands of them, potentially thousands of them. Do I make IT put it in the warehouse? Do I put it in a separate database, maybe an analytical data mart that I've got? Do I keep it on my desktop? Or do I calculate it every time I need it? And those bins might change. The high, medium, and low, the values that are cutoffs for those, they might change over time. So you have to think about that, right? So there's a whole lot of IT that has to happen, in preparing the data, and what are we going to do with it, where are we going to store it, how are we going to explore that data, who's going to explore it, what are the distributions, what does it look like, can I graph it, that kind of thing. And then, even building the models. I need to know something about the data before I build the models. So, if I use a regression, and there are missing values in the data, the algorithm is going to kick out any row that has missing values. We have lots of missing values in our data. Sometimes 40–60% has at least one missing value. Do we want to get rid of 40 or 60% of our data? Maybe. Maybe we want to impute those missing values. Or maybe we want to use a different kind of technique, a different method, decision tree, something that doesn't care about missing values, right? So we have to think about that as we model it. And then, once we're done the modeling, our analyst people, they're like, okay, done, moving on to the next project. But then you have to put that model into production. Maybe the production environment isn't the same software that you use to create the model. You might have created it in SAS, and my deployment is PL1 or COBOL or some other horrible thing on the mainframe, right? And so we have to maybe recreate the models and test them to make sure that their values are still coming out correctly. We've got to deploy the model. IT environments have very tight environments where they may only be able to put a model in production once every couple of months. So when does that happen? And then we evaluate the model and results. Now this looks like a great process, right? Nice, go around. It's not exactly how it happens. So exactly how it happens is I identify the problem, I look at the data, I say, we don't have enough data. We need external data. There's something the matter with the data. We got to fix the data. We do some data exploration. We figure out what the dictionaries are. We do some transformations. We build the model. We come out with some results. We go back to the business, and they say, that doesn't make any sense, right? So this process, then they go back to the drawing board. Maybe we misunderstood something. Maybe the data is wrong. So it kind of goes like this. And then this part, which you would think, once I've got the model built, deploying the model is the easy part, right? It's not. It sometimes takes a year, 2 years to put a model into production, and the world has changed by that point in time. The underlying assumptions that you used to create the model has totally changed. Who's going to use the model in this deployment environment? Who is going to actually be using it? Is it an end user that's going to look at a spreadsheet? Is it a transaction system, like a campaign management system? Is it another tool? Who is going to use it? You know, all this deployment piece, if I'm only going to make decisions, say once a month from a forecasting perspective, why would I need to collect hourly data? It doesn't help me if I'm only making decisions once a month, right? So you have to look at this whole piece of the life cycle as you're thinking about solving the problem and then putting it into production. Okay, so keep this slide in mind. Now, let's think about analytical maturity in your organization. And inevitably, when people see this slide, they put their organizations in a bucket, in one of these levels. So, you know, everybody's got levels of analytical maturity. We've got 5. A lot of people have 5. Davenport has 5. Many other people have 5. But down here, we're kind of analytically immature. You have probably 1 or 2 people, information maverick, that might be an engineer, might be a statistician, that knows something about statistics and is trying to do the best they can, helping the organization utilize their data and make better decisions. Here you might be within a department, right? And they only use predictive analytics, the data mining, the forecasting, the OR, in mission critical areas. But not everybody understands it, not everybody cares. And then kind of up in the level 3, you're getting maybe interdepartmental, and then moving up to enterprise type things. And up here, they start to think about centralizing their analytical resources and becoming more strategic about the use of analytics, right? Putting together this center of expertise. So people invariably put themselves on one of these levels when they see it, but it's more complicated than that. So let's go back. This is an idealized version of the process of analytics in an organization. If I am at a level 1, okay, I probably have a couple of people, and I probably have some desktop technology, spreadsheets, maybe some other desktop technology that I'm using. I have virtually no automated processes. You know, I might be writing things down and tacking them to my bulletin board so I make the same report the next month, but there's virtually no automated processes. In level 2, we can probably go a little bit further, and maybe they're building, you know, 1 or 2 predictive models, right? And level 3, we kind of start to build out, but even level 4 organizations don't have this part of the process down very well. That's the hard part of the process. And if you're actually evaluating, monitoring results and feeding them back into the next model, you're pretty advanced, because it isn't happening in most organizations. So most organizations that we see are somewhere here between a 2 and a 3. And a couple are up here at a level 4. Right. Now, let's take one more dimension of this. These things are actually people, process, and technology, right? I talked about people in level 1, process, technology. They have some people, they have some technology, they have no processes. So it gets even more complicated. So when we go to talk about business analytics maturity, we have to think about all those things. We have surveys that we give to both IT and to the business people, to the analytics people, and we evaluate all of these dimensions so that what we do as a next step is we put a plan together of how you move forward. What are you missing? What do you need? Where do you want to be? Here's kind of your current state. Here's where you want to be. And let's put a plan together to get you there. But it's people, process, technology. The technology part is the easy part. It's culture too. Culture's a little bit harder to change. But really it's kind of combining these two thoughts and overlaying people, process, technology on that. And really organizations that are good at this, they use analytics across the entire organization. And really they use the same techniques, those data mining, forecasting, optimization, across all those organizations. If you're looking at the marketing department, you're more likely to be using data mining. If you're looking at the supply chain side of your business, you're more likely to be using forecasting and optimization. Right? So it's different. HR could be using both of those things. Financial could be using both of those things. But typically it's one or the other. So when we actually do the assessments, we try to do it one business unit at a time and not try to put all the business units together. But we absolutely have to have IT, business, and analytics on the same page, level set them on kind of what is analytics, the data prep for analytics, all the types of things that we kind of just went through, but we go through in depth. Who are the people that you need? What are the skills that you need? How do you advance those skills? That kind of thing. So current trends in analytics. Certainly there's all kinds of ongoing research, and we have to adapt to that. Looking at modern techniques, we just put a random forest, which was a brand new algorithm, into our set of algorithms. We're looking at these computational implementations. You know, all this technology is coming out. You've got in-memory, you've got in database, you've got grid, which isn't new, but which are the right things that you should be looking at in your organization? What are your issues? Do you have throughput issues? Do you have modeling issues? What are the issues and the constraints within your business that would lead you to one technology or the other? I'm hoping we don't have to have an evacuation. and combining these techniques together. The thing with analytics, people talk about it as it's this one big thing, but it's not, right? Good data miners are not necessarily good forecasters or good OR people. They're different skill sets, and people usually go deep instead of broad, and that's why in a center of expertise you need backgrounds that are coming together to help solve problems. You need backgrounds from different industries. I work with all the different industries, and it used to be when customers would come into our briefing center, they would say, give me the best practices of whatever industry you're talking to, right? Now they say, give me the best practices of people who are not in our industry, because we want to take those best practices and bring them to our industry. And so you might be sitting in a presentation and you think, oh my gosh, I heard about that in the healthcare presentation, and we use that same process over here in new product forecasting for retail. It's the same methodology applied to something different, and that's where people who look at broadly across different industries can help bring those best practices from one to the other. Knew I was going to run out of time. A lot of these things I've touched on through the first few slides, and these slides are all in the proceedings. So, I mean, we really have to, there's a talent gap. McKinsey has told us that it could be huge, so we've got to figure out how, in analytics, how are we going to democratize analytics, get more people using analytics, not necessarily building the models, but using analytics, right? And some of the ways that we do that is we build best practices into the software. So you can build a really, really good data mining model with picking the target variable, the variables that are going to be in there, and saying, I want a basic model, an intermediate model, and an advanced model, and you push a button. And it already builds in the best practices from data miners across the globe, basically, to get you a really good starting model. Your senior people, you only have a few senior people, right? You want to make sure that you can spread out the load to other people in the organization. That would be a great thing for a junior person to do. And then make that available, if need be, to more senior people in the organization. Similarly, we build those kinds of best practices into other software. We talked about visualization, right? Everybody can look at visual trends, find anomalies, even on billions of points of data, right? If it's represented correctly, and find anomalies, find things that are interesting that then they could pass on to other folks. In our visual analytics, we have actually put in correlations and forecasting and some more advanced kinds of analytics other than just BI and reporting. And people often ask me, aren't you letting people run with scissors if they don't know how to interpret this? Yes, but we try to make them blunt scissors, right? So we try to give them information about correlation is not causation, explanations of what the values are, those kinds of things. So we are trying to help expand that. Here's the slide about the projected gap in talent of analytics versus demand. It's a McKinsey report. We talked about text. And then, big data. It's all coming at you very quickly. And I'm sure we've all heard the V's out of there, but what you're trying to get to is that relevant data. You're collecting all this stuff, and you want to get to that relevant piece so that you can make better decisions and getting through that information overload. That's our definition of big data. It's really when you exceed your organization's storage or compute capacity for making timely decisions. So very relative. If you feel like you don't have the capacity to make the decisions in that time, it doesn't matter whether it's a gigabyte or a petabyte or whatever bytes, right? It is really very individual. And we look at this changing IT environment. All of these things, these technologies, our customers are adopting. So we've got to adopt the technologies with them and help you understand how it's going to impact that life cycle of analytics. Where will it change things? The life cycle won't change, but the relative time that you spend in each one of them may change. The shift of the burden of all this data management and pulling data from data warehouses has largely fallen on the analytics community. Not what we were trained for, right? There's lots of people who can do data management, figure out star schemas and how to pull stuff out of databases. Maybe they should be doing more of that. And as we get into this bigger data, they're going to have to take that burden back. And we're going to be focused on the modeling pieces, more and more of the modeling pieces. But all of these things, how do we handle streaming data? How do we store it? How do we take advantage of the different kinds of storage that are available for us? Open source. Everybody is thinking about Hadoop. Everybody's using R. How do we incorporate that into our analytics lifecycle and how we're going to evaluate data? So why isn't everybody using analytics and level 5? Because there's lots of challenges, lots and lots of challenges here. The growth, the data, new types of data, all those kinds of things. The resources, big challenge. And still, the biggest challenge is that data piece. So here you see a survey from Bloomberg. Still, the #1 problem, data quality, data integrity, data consistency, and access to the data. Huge. Yes?
Two quick questions I have. One is, how much do you see the executive lack of blessing analytics?
So the question was, how do you see the executive kind of lack of blessing impact this? We still see a lot of executive interruptus. It's a Latin term.
I don't see that here in 2025. Because
It definitely
you
is.
could hire the staff if your VP bought in the idea of analytics, right?
Maybe you are constrained on costs and you have to, so, but that definitely is one of the other ones, and it comes up in other surveys, is executives override the decisions of the analytics. They still rule by gut feel.
And second thing I have felt is that this big data, now people are talking more about this as a gimmick more than real, and this is a turning off point for some executives. Yeah, it's a buzzword and it's nothing.
Actually, if you see the latest information from Tom Davenport, I think it was published in Harvard Business Review, he says that there's a lot of companies that are still using small data versus big data, right? So we're all talking about big data, and it's true that the top end of these customers do have big data challenges, right? And here's the thing, like from an analytics perspective, we have all been really good at taking shortcuts to analytics because we can't process big data, right? We learn how to sample correctly. We know that we only have a certain time frame to do the analysis. So if it takes me 18 hours to run some kind of algorithm, am I going to try another variable? Maybe try something different? Try a different algorithm instead of regression. I've always used regression. Maybe I should try a decision tree or a neural net. Not going to happen, right? But the new technologies that are coming out for big data will allow us to shrink that time. And it's not the time savings, it's how you would do business differently, right? What could happen if you could actually let your algorithms iterate to optimality instead of chopping them off at 3 hours, right? And there's all kinds of things. If you were sitting in a room and it took you, 20 hours to run an optimization, let's say on multiple marketing campaigns in your organization, right? You've got 20 marketing campaigns going on. It takes me 18 hours to run that. What if I could run it in 3 minutes? And we could all sit in the boardroom around the table together. And we could say, you know what, if I took $100 from you or $1,000 from you and I gave it to you, we could optimize all these together. And we could make a decision in an hour. The best decision for our company instead of doing it in stovepipes, right? So there's all kinds of things that this big data and big data technology will afford you that will change the way you do business fundamentally. So yes, big data is a buzzword, but there are really companies that are taking advantage of the new technologies to change the way they do business. And they will think of things differently, and businesses will change over time. There's organizational challenges. We talked about these, and I know that I'm right up against the time. We want to kind of align those things. Again, these are in your slides. We've got lots of books published on this stuff, and we have worked with just tons of customers to help them move their analytical maturity levels up. Again, the center of expertise is really, really important within organizations. One of the roles of the center of expertise is actually to do the work, but another one of the roles of the center of expertise is to actually enable, somewhere back in these slides, enable the rest of the organization, right? So here's your center of expertise, and there might be other business units in your organization. One of your responsibilities is to enable those people to do a better job. Again, to kind of hand off the burden to other people who can do things. The center of expertise might still keep all those strategic projects, right? But the other projects, they may hand off and help people understand how to run with scissors better, right? Yes?
What do you know that, or what signals are you looking for to tell you that your business is ready for center of expertise?
So some of these surveys kind of help it and where you are in that process and help you to evaluate where you are, and then we put together recommendations for the kinds of things that we think would benefit you short term, medium term, long term, and kind of put that roadmap together for you to help you figure that out. Yes?
Do you have any examples of sort of similar analytics and expertise like in
The question was, do we have analytical reference, let's say, for analytical center of expertise in universities? I am sure there are some, but I don't have one off the top of my head. But I could actually investigate that for you.
NC State.
NC State actually has the Institute for Advanced Analytics, but are there a center of excellence that does all the analytics for the rest of NC State? There could be. Yes?
Kathy, can you talk about the hardest part of getting a lot of this done is the integration of IT with analytics? Can you speak to what skill sets should be in the center of excellence and some maybe best practices about how to translate what they're doing into systems and processes?
I couldn't hear that last part.
What are some best practices perhaps around, the skill set that needs to be in the business analytics group to allow them to work more seamlessly in IT?
Yeah, and I'm happy to take that offline. That's one of the things that we do address, and I didn't really get to the center of expertise, but the center of expertise really has to be wide backgrounds, diverse backgrounds, data mining, forecasting, operations research, statistics, engineering, some other types, depending on which industry you're in, kind of pulling them all together. And the more people you have and the broader that you can get, the better. One of the things that we find with centers of expertise, they have to report to a very high-level executive, usually not IT. The ones that are in IT struggle. So usually not IT. Some kind of CFO, whatever, executive, but they typically have not worked well because of the pressures around IT and reduced costs. And a lot of the things that we do in analytics are exploration. And we may spend 2 weeks going down a path of building a model that we find doesn't generate anything. And that just doesn't fit with an IT business model, right? Yes?
I guess follow up on that question. Should there be IT people who know how to connect to the data warehouse, who know how to build data marts, and build tables, and so on? Should those people actually sit in the center of excellence, even if they're not predictive modelers, they're just data modelers who understand what the predictive modelers mean?
Definitely,
Should they
definitely.
be actually sitting reporting to the CFO, CMO?
Yes, the question was, shouldn't people who know information management, IT, about the databases, shouldn't they actually be part of the center of expertise? And absolutely, we need those people as well. Whether they're physically part of the center of expertise or whether they're dotted line, but those are totally critical skills that need to be there. Again, because we want to offload from an analytics perspective, we want to offload that information management part of our jobs today. Yes?
So a follow-up question in terms of your experience, center of expertise, thinking about what would be the best person as a person with IT or STEM or I guess because what would be the best skill sets for a person to be that set?
The best, I'm sorry, I couldn't catch it.
So like you need someone to lead that center of expertise. What kind of skills should that person should that person come from IT or come from STEM or
The person to lead the analytical expertise should have broad range of analytical skills. They should be an analytical person, or at least have the background to be able to manage and grow. There's a whole section on managing and growing the people in there. What's their career path? How do we make sure that we're expanding and enabling and all that kind of stuff? So they do have to have a broad range of skills, but they do have to. The leader has to know analytics. Yes.
I think you've got a couple of people from operation who can expertise. How can you deal with the problem of lack of visibility involving
Lack of.
business domain? People from sales, finance, they get together in the center of expertise. So they're not part of operation. How can you deal with the future? They're going to lost touch with operations. You're going to be always centralized around the techniques. How can you
There needs to be virtual communities, right, so that they don't lose touch with all this stuff. And part of the enablement, part of this mission is to make sure that we have virtual communities, and communication is so huge. Making sure that communication is going back and forth, and again, that we are communicating with the same language so that we know what we're talking about. And it is vital in the beginning to have a good, solid team. Again, you might be able to decentralize at some point in time, but it depends on the maturity levels and how things are working, and very organization specific.
From your observation, are you seeing that enough schools are training enough broad skills into a program of OR?
I would love to see many, many, many more universities create more programs, more undergraduate. We've got Ken Chelst he's creating OR in high schools, which is an awesome initiative that he's working on. Getting that analytics as far down as possible and creating more analytically savvy folks. I would love to see many, many more
IT
programs.
in the grad school environment, maybe one program or 2 courses and some IT background.
Yeah, and the skills that are, becoming prevalent even with these data scientists, they know databases. They know analytics, but they know databases, they know Java, they know Python, they know all these new techniques that, you know what, typical analysts don't know any of that. So that skill set has to come together.